Alright, the end of that last video, the camera shut off on me. The last thing I wanted to say, I was showing you this example with two complex conjugates being multiplied together. Remember, conjugates are where you have the same two terms, but one has a plus, one has a minus in between. And when you multiply them, I showed you that you end up with a real number. That's always going to be the case. When you multiply two complex conjugates together, the answer will always be a real number. Okay, so the product of complex conjugates is a real number. Okay, that's going to be important as I go actually into division here in just a moment. Actually, let's go right into that. So, with division now, let's say I wanted to divide two complex numbers. Now keep them simple. Let's make them just monomials for a moment. Let's just do something like 8 divided by I. Okay, it's a real number and an imaginary number, but they're both considered complex numbers, so this is okay. Basically, it doesn't make much sense to have I in the denominator because we want to write our complex numbers in this form a plus bi. Okay, kind of like we've been writing it before. And so an I in the bottom doesn't really fit that form. So what I want to do is get rid of the I in the bottom, and what we're going to do, because I is really a square root of -1, we're going to treat this just like a root, like we did when we did dividing of roots a couple sections ago. And I'm just going to multiply the denominator, multiply it by itself. Right? So if I multiply I by I get I squared. If I do that to the bottom, I also have to do that to the top, anytime you work with fractions. So on top, I'm going to end up with 8i. On the bottom, I get I squared. But remember, I squared, because I is a square root, it disappears, and you end up with 8i on top. I squared is really -1. That's how we get rid of the I, is we turn it into a -1 by multiplying top and bottom by an I. Now I can simplify this, right? 8 over -1 is just -8, so I could just simplify this to -8i. So 8 over I is really -8i in the standard a plus bi form. Alright, let's look at another example. Maybe one a little bit more complicated. Let's do 5 over 7i. Okay, so here I'm going to multiply again the top and bottom just by that I to get rid of it. Okay, so I want to multiply by I to the bottom and to the top. The top becomes 5i. The bottom becomes 7i squared. Well, remember, I squared is -1. So we get 5i over -7, right? 7 times -1. And if I want to write that in the standard form, a plus bi, the a is 0. The b is -5/7. So this is -5/7 times I. That is the a plus bi form. Remember, in both of these cases, the a is 0. Okay? Alright, so again, we're writing these in the form a plus bi. Alright, let's look at a couple more. Let's do something like 3 plus I over 4i. So again, I've got that denominator with an I in it. I'm going to multiply top and bottom by I. Now when I do that to the top, I actually have to distribute that I to both terms. I can't just multiply, pick and choose one. You have to do both. So the numerator becomes 3i plus I squared. The bottom becomes 4i squared. I can simplify. Both of the I squares are really just -1. And then I can split up my fraction. Maybe I'll do this in a couple steps here. Let's split the fraction. So that becomes -3/4 I, right? 3 over -4 is -3/4. And the negative 1 and the negative 4 make a positive 1/4. And now to get the standard a plus bi form, I want to reverse these to get the I at the end. So this becomes 1/4 minus 3/4 I. And there's our a plus bi. Okay. A is 1/4, b is negative 3/4. Alright, now we're also going to look at more complicated denominators. Notice I've only used imaginary numbers on the bottom. I can also use bigger complex numbers with a plus bi on the bottom. So something like 6 over, let's go with 2 plus 3i. Okay, 6 over 2 plus 3i. So here, if I were to just multiply by the I like we did before, we just multiplied top and bottom by I, notice up here, if I do that to a binomial, it distributes, and I end up not getting rid of the I. So if I put an I on the bottom here, it distributes. I'm going to have a 2i instead of a 3i, but the I is still down there. That won't work. Instead, we're going to utilize this idea of conjugates, knowing that 2 plus 3i minus 2, or times 2 minus 3i equals a whole number, a real number actually. I'm going to multiply now by the conjugate of the denominator. But if I do that to the bottom, I also have to do that to the top. When I distribute now, actually I'm going to save the distributing on top. I'm going to hold off on that for a moment. I'll explain why after I do this. On the bottom, I distribute. Now we've already seen, I took an example, we've already seen 2 plus 3i and 2 minus 3i equals 13. So I'm just going to put the 13 there. I'm going to skip the work, although I'll show you work on the next one. And now the reason I kept these separated on top and didn't distribute is because in some cases you can cancel the 6 with whatever's on the bottom. Like if this had come out to be a 12, I could reduce that down to a 1/2. I can't do that in this example because they don't reduce. So instead I am going to end up distributing here. But if you can reduce, you should. I'm going to distribute. I'll get 12 minus 18i on top. Still have the 13 on the bottom. To write this in a plus bi form, I split that up into 12 over 13 minus 18 over 13i. There's our a, there's our bi. Okay. Alright, let's try maybe one more of these. We'll make it a little bit more complicated. Let's go with 3 minus I over 2 plus I. Okay, 3 minus I over 2 plus I. So here, I want to multiply again by the conjugate of the bottom. So we'll have multiplied by 2 minus I to the bottom and 2 minus I to the top. Again, it must be the conjugate, so you have to change that sign. In the numerator, I'm going to go ahead and distribute these. Yeah. And so let's see, 3 times 2 is 6. 3 times negative I is negative 3i. Then I get a negative 2i. Then I get a positive I squared. So I'm just doing the distributing without drawing my arrows in. On the bottom, I can run through that as well. That's going to be 4 minus 2i plus 2i. Those always will drop out with the conjugates. And then a minus I squared. Right? The two terms in the middle add to 0. If I simplify this on top, this guy here is a negative 1, and this guy here is a negative 1. And so I really have, let's see, 6 minus 5i when I combine those. This is a minus 1. And on the bottom, still have the 4. And here's a double negative. A negative and a minus 1 makes a plus 1. And so on top I get 5 minus 5i, right? 6 minus 1 is 5. On the bottom I get oh nice, it's all 5s. So now when I split this up, I get 5 over 5 minus 5i over 5. All my fractions simplify, and this is 1 minus I. And there it is. That simplified it very nicely. Now the last thing I want to explain in this section is that I did all this work for you. Your calculators also can do this. You just need to turn your mode, if you turn your calculators on, go to your mode and make sure it's got the A plus BI mode on so that you can get your complex numbers out. And then if you want to calculate some of the simplifying problems, like we did square root of -9, it simplifies to 3i. And so your calculators can pull these off. Now I'm not encouraging you to use your calculator, get too reliable on it, but it is a nice shortcut, and it can even do some of these more complicated problems, like if I did this last one, of course in parentheses on the numerator 3 minus I, the I, where's the I? The I button, you may not be able to see it, is a second of the decimal. I jumped the gun there. Second and then the decimal button. Okay, so that's the numerator. Divide that by parenthesis, 2 plus second decimal. That gives me the I again. And that should give me 1 minus I, which is what we found at the end there. Okay, so your calculators can do these. You just need to have it in the right mode and then know where that I button is, which is again the second feature of the decimal. Okay, on most of your calculators. All right, so that pretty much concludes our talk on complex numbers. It's going to take a lot of practice to get this stuff down, but again, just treat them a lot like polynomials, except for those few exceptions where you have things like I squared equaling -1, and you should be just fine.